everyone. Today we're going to look at quadratics in regards to the cost, revenue, profit, and break-even points. So the definitions of cost, revenue, profit, and break-even are the same as they were before, except for the selling price. Before, the selling price was a set selling price, which we called S. Now we're going to look at a price that we're going to call P, which is a function of X. Remember, X is the number of units produced and sold, and P is going to be a linear function. So given P equals negative 30x plus 1200, find and sketch R of x. So R of x is the price times the number of units, so it's P times x. So we're going to take our P, which is now a line, multiply by x, and we're going to distribute the x across P. So we're going to get negative 30x squared plus 1200x. And then to graph it, we need those same things from before, the intercepts and the vertex. So the y-intercept is 0, 0. Notice that our quadratic is in standard form. It's ax squared plus bx plus c, and c is 0. And I can always do plus 0. So the y-intercept is 0, just like it was when our revenue was a line. It always went through the origin, so that's not going to change. The vertex, remember, is negative b over 2a. So negative b is negative 1200, 2a is negative 60, and that's going to give us 20. So the x value of our vertex is 20. The y value of the vertex, which we call k, is I'm going to plug in 20. So r of 20 is negative 30 times 20 squared plus 1200 times 20. You should do it out on your calculator to double check, but I'm getting 12,000. So our vertex is 20, 12,000. Next, we're going to look at the x-intercepts. And remember that we need the quadratic formula for this. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, the nice thing about the revenue is that c is 0. So this term is going to cancel. And I'm always left with the square root of b squared, which is just b. So I'm going to have here negative b plus or minus b over 2a. Again, this is only for the revenue because the cost is 0. Constant, c is 0. Okay, so this gives me either 0 if I do negative b plus b, which I already knew, or negative 2b over 2a, which is negative b over a. So I can simplify it, but again, it's only for revenue, so just keep that in mind. So I have the 0, 0, and then I have negative b over a, which is going to be 40. So I have 0, 0, and 40, 0. Okay. And then when I go to graph it, notice that I only have quadrant 1 here, because like before with cost, revenue, it only makes sense if I'm in quadrant 1. So the quadratic will go into multiple quadrants, but I'm only concerned with the quadrant 1 part. So the first thing I'm going to do is I'm going to plot my 4 points that I have, my 0, 0, my 20, 12,000, and my 2 x-intercepts. So in order to do that, I need to choose what values to go by in the x direction and the y direction. So if I look at my x's, you'll notice that I have 0 from the x and y intercept origins, I have 20 from the vertex, and I have 40 from my other x-intercept. So I'm going to want my x value of my vertex to be in the center. So I'm going to go by tens and just label every other one. For the y's, I have 0 for the y and x-intercepts, and I have 12,000 for the vertex. So don't forget that our parabola will be opening downwards. So my vertex is the maximum. So I want my 12,000 to be near the top. Oops. So I'll have 6,000, and then maybe make some more. So I'll go by 3,000s for each tick mark. Okay, and then I will plot my points. So I have the origin. I have 40, 0. and then I have my vertex right around there. And then hopefully those are enough points. I can tell how my parabola is going to look, and I've got my generic version over here. And then I'll just connect them into a semblance of a parabola. Okay. So again, the really nice thing about the revenue is it's always going to be a downwards opening parabola, and it's always going to go through the origin. So it's always going to look something like the following picture. Okay, so let's try another one. Given p equals negative 10x plus 10,000 and c of x equals 2,000x plus 1.5 million, find the break-even points. So the first thing we have to do is find r of x, which again is just p times x, so negative 10x squared plus 10,000x. And then remember the break-even points are when r of x equals c of x. So I'll set them equal to each other. And then we have a quadratic, and the only way we can solve quadratics is by putting one side equal to 0. So I'm going to move everything to the right because I like my a, my coefficient of x squared, to be positive, but you could just as easily move everything to the left if you preferred the x over there. The next thing that I did here is I divided everything by 10, and that's because that's my GCF. All of my a, b, and c are divisible by 10. And that's going to make plugging things into my calculator a little nicer. Okay, so if you can, divide everything by the GCF. Okay, so now instead of having a, b, and c be 10, negative 8,000, 1.5 million, they're a much smaller in comparison, 1, negative 800, 150,000. So then I plug them into the quadratic formula. Remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. If you simplify that correctly, and I suggest you do it on your calculator to make sure you're getting the same numbers, we should get 800 plus or minus 200 over 2. 800 minus 200 over 2, 800 plus 200 over 2 will give us 300 and 500. Now remember, it's asking for the points, so I need 300, comma something, and 500, comma something. So don't forget, make sure you're answering the question. I need the points. So if I plug 300 into either the revenue or the cost, I should get the same number out. And again, I want you to do it and make sure you're getting the same thing. But you should be getting 2,100,000 for 300. And when I plug in 500 into either of them, I should be getting 2,500,000. Okay. How about, given the following, determine the revenue, the profit, and the break-even points. So little p, remember, is the price versus capital P, which is the profit. So if the price is negative 3x plus 2,100 and the cost is 300x plus 240,000, then R is just P times X, and again I distributed the X, and remember that P is R minus C. So we have like terms in the middle. It's negative 3x squared plus 2100x minus 300x, that gives us the 1800x, minus the 240,000. So don't forget to distribute that negative across C. Now to find the break-even points, I'm going to set my profit equal to 0. And then if we notice, just like before, there is a GCF, and if we use that, it'll make our numbers a lot smaller. So if I divide everything by 3, the numbers that I need to use are a lot smaller. Again, I want you guys to go ahead and do the quadratic formula using these numbers or the original ones. It doesn't really matter. And hopefully we'll get the same number. So pause the video, do it out, and then unpause it. Hopefully you're getting 200 or 400. Then again, we need the points. So if I plug in 200 into either R or C, if it's asking for the break-even points, it means in relation to R and C, because the point, the y value point of the profit, we know is 0. So I'm going to be giving this in terms of R and C as my y value. So if I plug in 200, Again, you should do it yourself to make sure you're getting the same answer, but you should be getting 300,000. And if I do 400, I should be getting 360,000. If we graphed the three equations, we'd get the following. And I want you guys to check this math out, but I'm not going to do the whole graphing step by step. So C is the line. The green is the revenue. And the profit is the blow. So here is our break-even points in both the profit where they're 0 and the cost and revenue where they're the same, which is that 300,000 and that 360,000 that I just mentioned. So the only other points that we really needed in order to graph this are the y-intercepts, which are fairly easy to find, the x-intercept for r, and then the vertices. So there is a little bit more work in graphing these. We have a bunch of points we need to find, but it is graphing three equations, two quadratics, and a line. So just keep that in mind, but this is what the general picture will look like when we've got quadratics here. So make sure that you read through the book and try out the homework, and let me know if you have any questions. Thanks.